Hi, all. Welcome to another episode of Saturday Architecture. We also have Deepak with us. This week, I thought I had posted something on LinkedIn, and I actually saw this puzzle in another social media thing, and it really got me excited. So, what is this whole thing about? If you look at it, it's about a puzzle on how bananas can be. Now, this can be considered a lateral thinking puzzle. It can be considered a operation research, transportation challenge, and issue things. But at the face of it, it looks like this can't be done because 300 kilometers and 100, 300 bananas, which means three trips per trip, one banana, which means it can't be done. That is at the face of it. But that's not actually true. So let's take a very simple calculation here. And here, what I have basically considered is something like okay, there's going to be 300 bananas, total distance is 100 kilometers. One trip you can move 100. And I'm making a basic assumption that we will travel in three phases. Again, I had to think and take some help, and I did this basic calculation over here. And the biggest assumption is that camels camels do not eat bananas on the return trip. Okay, so there are 33. So if you look at it in phase one, consider it as different phases. And in phase one, I'm going to do 0 to 33. Second, I will do 34 kilometer to 67 and 67 to 100. Now, considering this, there are three trips which is needed, and that means a total of 99 bananas is needed, which means here this is a simple calculation. 300 minus 99 will give you 201. Okay, so that's how we end up with, at the end of the first phase, I'm left with 201. So similarly, you do it for phase two, I'm left with 135. And at the end of phase three, I'm left with 67. Okay, so this is my calculation. Now, one of the interesting things Deepak here pointed out, and it also struck me, is that we're making an assumption that camels don't eat they don't need bananas on the return trip. Now, if I take that into calculation, then it changes things drastically. So here, what is actually needed is instead of three trips, I have to count it as the trips is actually going to be five, which is a very important thing because going from A to B is 33, the return is going to be 33. So basically, I have two trips of 33, 66 into 2. So each trip is 66, 66 into 2 plus another 33, which means it becomes 165, which means that by the end of first one, I'm just left with 135. And when I do the second one, it is 36. And there is no way I'm going to get the bananas across. Now, this is fine. But considering that, now whether this problem is solved right, wrong is a different point altogether. But then I said, okay, so let me see what the LLMs do it, and I'll quickly run you through what each of the LLMs did. So here, to begin with, I took ChatGPT, okay, and I actually gave a very simple thing. All I said is answer, nothing else, okay. Now it did whatever it had to do, okay. It kind of split it, it did some things, and then it said, okay, I'm going to give 83 is going to be finally. So this is what ChatGPT said. Okay. Now it also says the problem is sneakily about optimization with stage logistics. Very good. Thank you. Okay. Then I went over to Claude. Okay. And they pretty much did the same thing. Okay. I didn't want to change the conditions. So I said, gave the puzzle and then said answer. Okay. So it also said I'm going to do it as a use a relay strategy. Okay, then it's fine. It did 0 to 33 and it did this. And then finally it told me that, hey, it can take 33 bananas to the market. Now this is Claude Anthropic. Okay. Now then I went over to Gemini. Okay. Same thing. Banana answer. Okay. And it did whatever its calculation. Okay. And it actually said the most logical and simple answer is 100 bananas. It's like, wow. So that's the first answer that it gave. Okay. Then I went over to same thing, okay, with perplexity, okay, and I gave the thing I didn't have to answer. It just said the answer is 50. Okay, so all these things did it again did its split, it again did its math, okay, and it had its own logic, and finally it gave it as a the answer is 50 bananas. Now I am completely confused. Okay, we've got four different frontier models, four different applications, each telling its own thing, and my own calculation telling something else. Now, this is not a theoretical thing. This is a real life scenario of reasoning and planning and making things. So, this is how real world problems presents itself. It is not a real Gen AI or a AI thing is going to face this. So, let's just go one more iteration and delve a little deeper. So, went inside ChatGPT and asked why three per stretch. Then it gave, and it says it gave an explanation that it eats one on the way back. And then it says, so I asked it a question, why do you make an assumption that on the return it doesn't need things? Then it says, oh, okay, thank you, that's a great catch. Okay, the assumption was the camel doesn't need bananas on the return trip as it is baked into the problem statement. As it is baked into the problem statement. Okay.
It never says that. It
Then,
never says.
then it made me go back and I looked at the problem statement. There is nothing which says that it will only eat when it is there. It is not there in the problem statement. So that's an assumption that is made. Now, interestingly, this is also an assumption humans have made. So you can't really blame the LLM or the AI for it. Okay. So so then it asked me, okay, do you want it to do you want that how many bananas if we remove that assumption and say the camel eats one per even when empty? I said yes, please do that. Okay, then it comes up with 53 and a half bananas. Okay, so it did this calculation. Now I'm seriously confused because uh, it did some
Only 30 less. Only 30 less.
yeah, but I guess there is one solution for this. I said that's fine. Okay, then I went over to Claude, okay, and it had made a mistake in the calculation. Okay, it said the number of bananas were
Wo-
correct. Then I said recalculate it. I gave it multiple chances and I just said calculate again. And then finally, Claude says 33 bananas. Okay, okay. My Excel with assumption it won't eat, it was 67. If I make an assumption it will eat, it was 66. ChatGPT said 83 and then revised it to 53. This one says 33. I left it. Then I went over to Gemini and I asked it like, how are you selling it as maximum? And then it does a calculation and then it's beyond my comprehension. I just couldn't understand what it was telling. I just left it. Okay. And then went to Perplexity and then it did one calculation and then it says the conclusion is 50. Then I asked it like, why do you make an assumption that bananas won't be needed on the return? Okay. So it says that this is would be written is based on the camel scoring carrying logic and the goal to maximize the number. Now, Where is the logic in that it camels won't eat anything? I don't get it. But somehow.
Yes.
Okay, then it goes on to telling something like stockpiling things at an intermediate and then gradually moving them forward and not habling them backward.
So
Now,
the assumption
then,
is saying is that when you are hauling it back, when you are not hauling anything, then you're not eating. That's the logic it is using.
yeah, and it's very interesting how the logic, why returning bananas isn't required, goal oriented. This looks like a typical capitalist bias built into the LLM, which says like I will beat the worker to death. I don't have to feed them, right? I kind of got that feeling like seems to be telling that I really don't give a damn. I just want my work to be done. Okay. Now, interestingly, that is a human bias or typical capitalist non-human profit-making bias that's actually built into the LLM. It just kind of revealed that. Okay, and then
But you see the, in fact, if you look at the responses which you got, a lot of people actually did not assume that you need any bananas on the way back.
correct. Now there's no
So
right or wrong answer.
it is reflecting the human thought, at least at the puzzle level.
Correct. Why assume bananas are not eaten? Again, it gives some vague thing, and then I gave up. I said so. Recalculated. I gave it a couple of chances. It did some things, some more things it did. Okay, and finally it said 53 bananas. Interesting. Okay, so for example, here it's actually splitting it. The first stage, it's just did it as 20. Okay, and then it says it's three loads. Okay, so it made, so let's say if it is
It is doing an
let-
optimization thing, right? It is doing an optimization thing. It's because the way you solved it is with three phases. He also solved it with three phases, but he has optimized it by reducing the
yeah,
load he has to carry. The segment, he has made the segments more optimized, so he can actually get more done with the optimization solution.
done some more optimization around that. Okay. So
Yeah. So instead of
um
doing 33, 33, 33, he just first 20, because anyway, after that, the load is going to reduce. We're just going to do more, less bananas he has to carry. You can go further. So the last, if you look at the logic, his last trip is, I think, more than 60 kilometers. How much is that? First trip is 20 kilometers. The second one is a little longer, and third one is the longest.
correct.
So use or I should say it used.
It used it. Correct. So I think the key thing which stuck me as I was doing this is which LLM is right, which one should I rely on, okay, and which answer is actually the correct answer. I have no clue. Okay, but
No, I think one of the key things which all people using LLMs should do invariably is to ask for the logic, the way we sort of backtracked as to why it believes is the and means finally it
yeah,
may work, it may not work.
that is fine for an experiment. But when you want to use it in production, you can't keep it. Oh, Ellie, explain why you did this. Explain why you did this. Doesn't work that way.
No, no, I'm saying while at least the devs should understand this thing while they're doing this, right? Until they are convinced that the logic which LLM is using, they should not be putting into production.
Ah, that's true. But that again gets it a thing like we'll take that up
We
later on.
cannot rely on
So
100% creating the application and the
no,
logic
this
and
is not
everything. Yeah.
the challenge here is this is not even 30%. Each LLM tells something else and it makes some assumptions. So I think
I think
this entire
mm,
exercise to me has given more questions than answers.
no,
Okay.
of course,
And
means I don't think there is an answer, but it is a, in a way, it is a cautionary tale, in that sense that
yeah,
you cannot blindly take an LLM into your production system without testing all the possible ways to do it. By the way, same thing happens with even cold our regular old algorithms also, right? Algorithms also fail the same way, just because somebody did not get the exception thing right. So I don't think it is as dangerous as as it would be not testing the extremes of the algorithm's limits. I treat it as if it was any other algorithm. Are you means you cannot, just like you need to test your algorithm, you need to test your LLM as well, as to what are the boundary conditions in which the
See, I
logic
think as
fails.
of now, everybody understands this. I don't think there's anybody using an LLM pushing it without production. Okay, so that's a given. But the key point here is
Yeah.
the test conditions itself is tricky. Okay,
Yes.
the hidden assumptions behind the test condition, right? In things like this. Now, why this is interesting is very good problems, very real problems in the world will appear like this. Okay, very poor problems will be well defined, good problems will be poorly defined.
I think that that problem, I would not say that it is drastically changed in the way we are thinking about it, right? We still need to do the same things which we always did when we did application development. I would say this is just another tool, which is, although it is a more
I
advanced
mean,
tool, whatever else you want to call it around it, but you all the same principles still apply.
what I meant was, it is like you can use LLMs to solve very low quality problems.
Yes,
Okay,
like maybe
okay,
producing a specific code, right, where hundreds of lines of codes is available for example.
specific code, generating an
Yes,
email, generating a response to a customer, like that. Okay,
yes,
those are,
yes,
I would call, mediocre level problems for which you can use AI to solve. But if you
yes.
want to
And a lot
solve,
of people find that, yeah, well, the reason why it's still being considered as a successful venture in that sense is because a lot of people believe that a lot of unproductive labor goes in answering those questions. That's what the
we might
value
have
of.
why we do that, and but
Yeah.
I think, and there are valid reasons, and there is another study which says 95% of the AI projects fail because of that also. But if
I
somebody is
seriously
looking
doubt
at,
that that logic where means I don't know where who came up with this 95% thing, and what the
it's an
logic of all
MIT,
this data is.
it has some data to it. Okay, that's debatable.
Yeah,
But the point, I
yeah,
think, is that if you are picking a high quality problem, it will be poorly defined. It will be poorly defined.
that is true.
Okay. And a high quality problem only will give better returns on investment. So the way how you
That
go
is,
about,
in fact, yeah. In fact, you see that's where when the whole ROI thing comes in terms of enterprises, right? When enterprises are looking for these whatever we call as 95% failed AI projects, is is they are unable to justify why they should put AI behind something, right?
hmm,
It's like,
correct.
of course, it's like the means at one point of time we had remember some other buzzword name technology and say everything has to have blockchain, right? So everything has to have AI now, right? So that those kinds of things actually, in fact, I was talking to another customer who now this what I'm going to explain is just a set of people who are actually not engaged with deep technology, but they want that whatever they are doing, it should be infused with AI. So the keyword is infused with AI, because all the work which they do is they this is a sort of a disaster monitoring team, right? This team gets inputs from various vendors, right, who actually are monitoring these disasters and generating these emails to places. So which area is going to be impacted by some disaster, so they collect all this data. So so they are very keen. He says, I want this to be now AI infused. I asked him, this is okay. Means of course, this is a lot of it is an automation task. We can read the AI can read your email and classify and do all kinds of things and highlight where the disaster is going to happen and all those things it can do. But why are you so keen about it? He says we want AI to be included in our workflow because that is the buzzword, and And I appreciate his honesty. He was honest about it. I mean, of course, it makes life easier for them to not waste time looking at emails coming from 100 sources and deciding which is the area of disaster. But that's the stage we are at. So, and now can I justify the effort which is going to go into building the AI for that specific solution? Maybe, may not be, but it comes from the background of infusing technology into specific areas, because it has reached that cycle. In the hype cycle, it has reached the point where everybody has to have it.
Yeah, it has. And time will answer how much of it will fly, how much of it will die a miserable death like that. Let's see. I think the key thing this taught me is, as a system, as individuals, as architects, as business owners, how do we look for a higher quality problem which we haven't typically solved? And what does a higher quality problem mean? And typically, a high quality problem will have very poorly or loosely defined contexts and constraints. AI will do its own random stuff, and then now, even in this video, let's put it out there, and I'm sure lot of people will agree to one LLM. Somebody will agree to what I did. Somebody else won't agree to this. So good problems will have this, and systemically, we don't have a way to handle these kind of conflicts. And the biggest danger is somebody goes and blames the AI for it not working, whereas it's more a process and a management challenge than an AI challenge itself.
Yeah. But basically, it boils down to that: why are we solving this problem with AI in that sense? That's the question which the managements have to answer before they start building solutions around whether it is worth doing it with AI. What is it? Because the I would say 60 to 70% of use cases which I get from enterprises, they are just pure automation. Nobody is thinking about AI in the same way as what you and I are talking about. That is it
Hmm.
really solving something which requires intelligence? Most of the time, it is just automation, maybe small sliver of AI decision making. 90% of it is just automation.
Deploy a miniature version of Iron Dome or to kill mosquitoes in the house. Track and shoot mosquitoes. Uh, Interesting.
Yeah.
Okay. So let's see. It was a interesting exercise.